because that would have been how much time has passed since t equals 0. So it's just adding on.
Okay, so it's 2 hours and 45 minutes.
Yeah, so it's like, we started 11:45, and then
90
90 minutes passed.
Got it.
And
That's
another
2:55.
2 hours passed, yeah.
Here, let me help you a second. So I'm going to use this first piece of information, and what it says is the temperature is 52. What's the M? 38. The C, E to the 0. I'm plugging in 52 and 0. You guys okay?
Yeah.
So very quickly, this is easy. C is here, and you move the 38 over, and you realize that C is 14. Got that?
Yep.
So that's cool. Now, I'll use the next piece of information, and I'll find K. Here I go. I'm going to plug in, what am I plugging in? A 40. This is 38. This is 14. E, I don't know K, but I'm going to plug in 165 minutes. And then I got to do a little algebra. When I subtract 38, that's a 2. I divide by 14. I get E to the 165K. You guys doing all right? I ln both sides. I'm going to change that to 1/7, by the way. That's what that is. And then I divide by 165. I think that's my K. And I could decimalize it, but it's almost better to leave it like this, maybe, and use your calculator later. But what is this, K? Go ahead and tell me. Negative point. It's small as hell, ain't it? Negative point.
Negative 0.011.
Negative point 0.
0. 1.
I think what it is
79.
that we all had our own little ways of understanding.
79.
Just try to incorporate everybody's at once, and then we just kind of do that.
339. 484.
Yeah,
All right.
that's how I felt that one day in class when we were talking about rescaling time.
But if you're doing it in hours, your K is going to be different. Yeah, anyway, but
That's not correct.
what?
Negative 011, not 2 zeros.
Oh, not 2 zeros.
Right.
Yeah, it's, yeah, we had 2.75.
0, 1, 1, 7, 9.
5 on the river, on the end.
And a 5 on the end. All right, thank you.
Get the same answer. I think it's 5.
Okay. So anyway, now what do you got? Now you got the model. You got the model. You got an unknown temperature, a 38 here, a 14 here. Is that right? E to the K. Here's the K, the natural log of 1/7 over 165. And now you're supposed, and there's T. So, you know, this is your function, right? You got inputs and outputs. You can input a time and you can get a temperature. Or you can input a temperature and get a time. Whatever you need to do. But this is the model. I mean, the work is sort of to develop this model and then answer the question they ask. And the question they ask is, what was that original temperature, which was negative 90 minutes before 0, what we called 0. So I think I should plug in a
Negative 90.
negative 90. And then, you know, this is where, right, you could have all this beautiful theory figured out and just screw up punching your calculator right here. I mean, you could. So try not to. A negative 90 times this negative number here, whatever that is. I mean, you gotta, you know, again, maybe I would do that, then multiply by 90, negative 90. Then I would E it. Then I'd multiply by 14. Then I'd add it to 38. Now, I don't mind somebody shouting out the answer here. This is number 4, take-home quiz. I'm kind of doing it with you or for you, but can you shout out the answer when you plug in a negative 90? What is the answer?
78.47.
Really? When you plug in
I
a
did it with
negative
hours, I
90,
got the same thing.
she
I did hours
gets
too.
Well, that's what I did.
78.5 degrees
right.
Fahrenheit.
She did it with hours, and that's what I got too.
So anyway,
Check it this way.
so I helped you with that. That's easy. Or whatever. But you might, it's easy to make a mistake too. I mean, I'm saying it's easy to do, but it's also easy to make a mistake and punch something in wrong and screw something up. So it'd be cool if you figured out your mistakes, before, that's your job before Friday. Clean up, figure out all your mistakes so you don't make them Friday, but.
It's the same in, so
Yeah, because then 55 is.
Yeah, it's supposed to be, should be.
Yeah, 165 over 60 is 2.
and see where
All right, so that was kind of fun.
okay.
Hey, what else you got? Any other requests or concerns on this piece of paper?
Quick question, what do you mean to the nearest tenth of a year? I just wanted to kind of clarify that.
Well, tenth, if it's 11.4721, can you round to the tenths place? That's the tenths place.
Okay,
So you don't want the year, you just want.
okay, just want to make sure. I was kind of confused on that. I was thinking it's the tenth of what? No.
Yeah. I don't know. Any other questions, concerns, requests? Anybody need a copy of this thing? This is a take-home. Do you need one? Yes.
Number 5.
Number 5 is the hard one.
Well, okay, I might help you with number 5 someday.
Someday.
I just don't know how to get that doubling in.
Oh, that's easy.
But I got everything.
When they tell you a population doubles, see, I can walk in here, if I say my population doubles in 20 years, basically I just told you K. Let me show you something. So what you know about population is that it uses this model, right? And if I say, dude, it doubles in 20 years,
Okay.
then here's what you're going to say. You're going to say,
T equals 20, Y equals 2C.
yeah, you're going to say, well, he never told me C. It doesn't matter.
Okay, I
It's
I did that.
It's gonna, in 20 years, it's gonna double to be 2C.
Okay.
So if I just walk in and say, the population doubles in 20 years, that's just a fancy way of telling you K. Well, what I mean is you can figure out K from that statement. And here I am, I'm about to figure out K. How do I figure out K?
Divide out the C's.
I divide by C, and it's gone. For a brief moment, you think, man, I don't know how I'm going to find C. But as soon as you divide by C, you realize it's gone, and you can definitely find K now, right, you guys?
Yep.
So that was just me making up a problem, actually. I'm sorry, I used the 20 years as an example.
Okay.
But, so in your thing, it says that it doubles every, what does it say?
Every year, once it reaches
Yeah.
36 degrees.
Right.
So that's what I was trying to figure out. Where in that second part, where's your T equals 0? Will be up to 36 years.
Hour.
Out. I mean 1.75. I mean 36 degrees.
Well, all right.
It's kinda confusing.
Let's not do that. Let's skip number 5 for now.
Oh.
Even though I just helped you with one idea, right?
Yeah.
But I don't want to help you with the whole thing yet. I might want everybody to work on it a little longer. Maybe I'll help you Wednesday with number 5.
Okay.
I mean, I'll just try to help you with the logic of the setup or something. But you know what I think is on the test Friday? Number 6 or 7. Something like 6 or 7. And basically 6 or 7 is from section 6.4. And you know, we struggled a little in 6.4. It was that logistic equation. And there was a DE that we didn't know how to solve. But these questions are kind of easy. I think you want this on your test Friday, number 6 or number 7. I think it's darn easy.
Yeah.
Yeah. But if you don't realize how easy it is yet, maybe you'd like some help with it. Do you want some help with 6 or 7?
Sure, why not?
Have you tried it yet?
Yes.
Yeah, like I said, the part D just kind of messed me up a little bit.
Yeah, okay, good. Part D is the slightly hard part, but,
I just started.
well then good. Okay, maybe you don't need me then for 6 or 7.
Yeah, just do one.
I mean, they are easy. You want to do one? Let's do 6.
Just do
All right, let's
one,
do 6.
and then that way,
So what does 6 say? 6 says that you got this differential equation. Now listen, I don't even want to write it down, okay? There's a differential equation there, and then here's the solution. The solution is, oops, I didn't mean to go purple on you there, sorry. The solution is 7,500 over 1 plus 29 e to the negative 0.52t. 7,500 over 1 plus 29 e to the negative 0.52t. what we learned is that this is the logistic equation. It comes from that DE that's written in the problem, but we don't know how to solve it, so we're just working with this solution, really. And the other thing we learned, let me just ask you something. Let me ask you this question. What's the limit as t goes to infinity?
7,500.
10,500.
Well, that was good. Good job.
That's the L up top.
You're right, it's the numerator, right. I mean, when I said, what's the limit as t goes to infinity, and you know that when you go to infinity, this is e to the negative infinity. E to the negative infinity goes to 0. 0 times 29 is a 0. You end up with 7,500 over 1. That's a long explanation of telling you that's the carrying capacity, and this graph looks like this. That there's a horizontal asymptote at 7,500. See, when I said, what's the limit as t goes to infinity, that's sort of a way of saying, what's the horizontal asymptote? Anyway, the answer is 7,500, and we have this sort of shape. So that's just real quick. That equation is roughly this shape. Might be helpful. I don't even need my graphing calculator, but it might be fun to put it in my graphing calculator, but this is good. So now, what are the questions? They're easy, aren't they? What's number A? Oh, we already did A. A is, what's the carrying capacity? It is that 7,500. It is that horizontal asymptote. It is the limit as t goes to infinity. You don't have to show me much or do much. I mean, I feel like in this class we've sort of learned that it's that number, so there's not much work to show. But it also is the limit as t goes to infinity, like I discussed. So anyway, cool. That's easy. A is easy. What was the initial population? That's also easy, but it takes a tad bit of thought. The initial population is
When t is 0.
the population when t is 0. You kind of need that thought, perhaps. And then it's easy. You plug in a 0, don't you? Right. So now I'm sort of plugging in a 0. That would be 7,500 over 1 plus 29 e to the 0. What's e to the 0? 1. 1 times 29 is 29, so here we go. This is the answer, right?
Let's work it out.
Plug in a 0, you get, so 7,500 divided by 30, 7,500 divided by 30,
It's 250.
250. What are these bats?
Yeah.
250 bats. By the way, that's right here then, look at that, that's right here. It starts at 250. That's the initial population, that's that initial Y value. All right, cool. So we got A, I mean the answer to A is this, the answer to B is easy, this is easy. What's number 3? Just part C, I mean. How many bats are in 1998, which is t equals 8, so what do you do?
Plug in 8.
Plug in an 8, plug in an 8. Right, plug in an 8.
For t.
Yeah. And I just randomly asked that, I don't know, I could have been anything, but that's all. Again, that's sort of a calculator problem. Can you plug in an 8 without screwing that up? Use your parentheses maybe, negative 0.52 times 8. You know, be careful with your order of operations. Get that denominator done. Divide it into 7,500. You can tell me the answer if you want. This is part C.
5163.
Yeah,
What'd you say?
5,163.
5,163 bats. Wow. That's kind of cool.
Now, we rounded that, and the number in the tens place was 0. But if the number was like a 7 in the tens place,
Well, you can't
can
have
we
7
just
tenths
keep
of
it
a
down?
bat.
So because we can't have part of a bat, would that be okay?
Okay.
Miss Beth's
Yes.
like a third.
It would be okay. And if you round it up, it would be okay. I don't really
Care.
care.
I just want to.
I act like I care about the
I don't
number of
wanna ask
bats,
you
but
on
I
the-
kind of don't really care about the
I don't
number
want
of
to
bats.
ask you on the day of the test.
Well, no.
So
It's an interesting discussion about rounding up or rounding down, but the truth is, I'm going to accept your logic either way. I don't want to get in a logical argument with you. So,
Very good.
okay, so this is an easy one, and I'm suggesting this is on Friday's test. This number 6 on your take-home quiz would be nice free points. Now, we did just get to the hard part, though, part D.
Yeah.
By the way, what did we just, I just want to illustrate what we just found in part C. What did we just find in part C? That after 8 years,
Yes.
we are roughly at
5,160.
5,000 bats, I guess. Okay, I'm just trying to illustrate that for you. But anyway, now part D wants to know this. To the nearest tenth of a year, when will the population be increasing most rapidly? And maybe we've had these discussions, but it's increasing most rapidly
At the inflection
at the inflection point.
Mm-hmm.
Finding the inflection point analytically, we did Friday, and that was rough and tough because it was a tough second derivative, blah, 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 blah. What we've learned about these logistic equations, though, we can use. And what we've learned is that the inflection point occurs when y is
L over 2.
half the carrying capacity.
Yep.
which is
So-
3750 in our
So this is going to happen when y is 3750. But wait a minute, I'm looking for the t. So you got to find the t when y is 3750. Half the carrying capacity. Half the 7500. Are you guys okay? And this, we had this discussion a few days back, this exact discussion, but here it is formally on a take-home quiz and on your test Friday. So, cool. This is kind of fun. You plug in 3750 for y, and you try to solve this equation for t to find the number of years. By the way, you can sort of estimate. Look, remember we plugged in 8 years and got this answer?
Yes.
So just estimating, I might say 6 or 7 years, but
Yes.
anyway.
It is.
But you guys all right?
Yeah.
Everybody? All right, so what do? We do a little algebra. Multiply by this, divide by that,
Yep.
and when I do, that will be 2 over there, I think. When I multiply this up here and then divide by 3750, the reason that's half of that is that'll be a 2. Now what? Subtract 1?
Yep.
See, if you do 2 or 3 of these, they're always the same, right? So now this is a 1, and then I'll divide by 29. So it's 1/29. I'll take the ln of both sides.
Okay.
And t will equal the ln of 1/29 over that negative 0.52.
Yes.
Now, can you execute that on a calculator correctly?
6.5.
6.5. And you're rounding to the nearest tenth of a year?
Tenth of a year, sorry.
6.5 years. Okay, thank you very much. I mean, this idea was up in 6.4. There wasn't a lot to practice in 6.4. And by the way, you can tell, I'm not doing too much calculus sometimes here in chapter 6. I mean, we kind of, anyway, this is very algebraic, right? I didn't prove that this was, I gave you this answer, and I'm doing a lot of algebra with it. And my word problems, my word problems on the front page are very algebraic. That's kind of how those word problems are. We did the DE, we got the solution, and they turn into algebra problems, kind of. There is some calculus on here somewhere. I guess starting with 8, 9, 10, 11, and 12, those are, you're solving DEs, you're integrating, you're doing some calculus. Any other particular requests or concerns maybe about this take-home quiz or anything in the book? We spent a couple days working on problems in the book. I feel like we're good there maybe. Anything else on this take-home quiz?
Number 12.
Number 12? I mean, yeah, I mean, it's probably the toughest one on there. That's why it's number 12. I tend to do things like that, put things in kind of order like that. I don't know if all right, so because it's a take-home quiz and I want you to think, here's how I'm going to help you with number 12 by I'm going to help you with number 12 by shutting up, and you have to tell me what to do. So let's see what this is. This is y square root of 1 minus x squared, y prime, wow, minus x square root of 1 minus y squared, minus square root of 1 minus y squared equals 0. There's an initial condition on here. Wow, you guys. All right. It does say you can leave the answer implicit, it says, but that's, thanks a lot. All right, so I'll shut up. You tell me what I should do. What should I do?
Move the negative x square root and the other square root negative to the other side, make them positive.
All right. I think I like that idea.
Yeah.
He said move these dudes over there.
Yeah.
By the way, if I move those dudes over there, then what's left over here is this, right? And I'm going to rewrite that y prime as a dy dx. But then he said move those other dudes over there.
Right?
Yeah.
All right, I'll just move them all there. So that's a positive x square root of 1 minus y squared, and then this is a positive square root of 1 minus y squared. Right, you guys? Is that how I do it?
Yep.
Just move those terms to the other side. All right, so now what?
Factor out square root of 1 minus y squared.
Hey, did you guys hear that?
Yeah. Yeah.
What'd she say? What did she say? What'd she say?
Do it.
Factor out.
Factor out this square root thing on this side? Yeah, I think that'll help me. You know what? On your quiz you took Friday,
Yeah, now I know what I
there was
do
some
wrong.
factoring that a lot of people missed, but that would have helped. It was easier in this one, but there was still some factoring. That factoring move helps a lot. So if you do factor that, what are you saying? You're left with
X plus 1.
x plus 1, because you factor out a square root. Yeah. This is this. This is this. All right, I'm getting close to, I bet you I can start multiplying and dividing and get
Yeah,
this
switch
thing
it.
separated. I'm trying to get it separated.
X plus 1, how did you get that? I'm sorry.
Okay, I factored out, let's see. So this had a square root, plus this guy had a square root. So I factored out the square root,
Oh, okay.
leaving a 1 here.
Okay, I see.
Now you switch,
So now I'm multiplying the dx over here,
right?
which means I want all the dx's, I want all the x's over there. So I want all the y's over here, so this will come here. What about this? This will come,
Over there.
can you follow the arrows? That's perfectly clear, isn't it?
So y over square root minus y.
It is sort of clear. What's going on? So this x plus 1, that's staying there. The dx is coming up there, and then what else is going over there?
The square root
This
of
square
1
root's
minus
coming from
x
the
squared.
denominator.
That's in the denominator, right?
What about over here? This y is staying here. This dy is staying here. Anybody else coming over here?
The square root
This
of 1
thing's
minus
coming
y
over
squared goes to the denominator.
All right. Woohoo! We got it separated. We got it separated. We got the x's with the dx. We got the y's with the dy's.
Now we integrate.
Now we have to integrate. Right. I'm integrating this side with respect to y, and I'm integrating this side with respect to x. They're subtly different.
I would say we start U7.
Yes, I think a u substitution is appropriate for this integral. And then, but I got another complaint about Friday's quiz. See, this leads me to a thought on Friday's quiz. On Friday's quiz, I kind of had an integral like this, and y'all might have done u substitution, but then, so this is if it is u substitution, then is this a square root of u? In the denominator, it's a square root of u? So how do you handle a square root of u in the denominator? What do you do with that?
I make a u to the 1 half.
It's not an ln.
It's a negative 1/2.
Negative
It's on the
1/2.
bottom.
It's u to
You
the
move it up and you
1/2.
call it u to the negative a half. Right. So several people went ln on me. That's not good. Some people moved it up and called it u squared. That's not good.
Got it, yeah.
So we had some errors on Friday's quiz. I'll show you those in a minute. But it was similar to this kind of thing. Bless you.
Thank you.
Hey, all right, what about over here? What do you want to do here on this one?
You said.
I separated it.
Separate.
I separated it. I put the x over the bottom plus the 1 over the bottom. And I want to ask you, I saw the one on the right is going to be, is it true it's going to be an arc sign?
Yes.
Okay. All right. That's how I wasn't sure.
Hang on, you guys hear what she's saying? All right, so I'm not doing this
Yeah.
integral for you right now. Look,
Worked on this.
this integral's sitting here, right, you guys? But on this side, I have a suggestion for you. Separate it. Make it an x over that square root. And then make it a 1 over that square root. And then sort of treat it as two different integrals. I mean, right now they sit there, they have a common denominator. I'm busting it up so it's two separate fractions. But now, that's how you do integration a lot of the times. You integrate separate terms. Added and subtracted separate terms. And so, and then, you know what she said about this one? This is a unique little guy. This is u substitution. In fact, it's the same u substitution. These are the same.
Yes.
But this one is, she said, this is arc sign. She's right.
U over a, which be x.
It's kind of an easy, just arc sign of x. Plus c.
Yep.
But there's some more work to be done here and here. I might just stop here. I'm helping you with this problem, but I might quit helping you. I got you pretty far. So that was, it's 12. It's a tough one. I wanted you to, yeah, anyway. It's not that tough. I mean, in a way, you know, you can handle this anyway. You can finish this. What you needed was sort of the organization at the beginning, I think. It's kind of what you might have needed, but whatever. What else you got? Any other good requests? That's right. At least you're honest. Let's do this. Let's take a look at Friday's quiz that we did. Let me show you this Friday's quiz. Well, there's only 4 questions. I guess there's 6 1/4 points each. I take off 3 or 4 if it's major, 1 or 2 if it's minor. Anyway, and you get a 25-point quiz grade. So you can learn from these mistakes and improve for Friday. Let me just give you these.
So I was checking my stuff right before I had to go, like